Hello. Yesterday it kind of sucked because I don't know. It was just weird. But today, this is where I make my redemption. So I'm actually starting a bit earlier than I usually do. I thought I could fit one game of CS, but then I had to shit, which that's unfortunate, I guess. Because it's Christmas and I am home, I get to eat much more than usually. And oy, so that means I shit more, and my ass, bro. My ass is properly torn up. Hurts. Yeah. Stop with the yappage and get to work. Yeah, so I'm about to start complex numbers. So what's left? Complex numbers, and then how you call this in English, bro? I got imaginary complex numbers, sorry, which should not be that tough. We're on a couple of slides here. It's yes, and then I have series and sequences, which I don't want to do. Yeah, but I think that's it because yes, realms, algebra, functions, polynomials, equations. Yeah, so I think yeah, complex numbers and after that series, and after that, like just doing problems from everything and everyone. Okay, so let's start. Open up my software. Don't leak anything. Save as complex numbers. Save. Now, screen capture, open selector. Yeah. Oh no. Grab the wrong thing. Transition. Yeah. Okay, man. Here. So basically, complex numbers is what arises. Wait, I already. What the fuck? So let's say you have an equation like x equals square root of 2. But what if? So that's like x equals plus minus 2. But what if it x square root of minus 4? Usually you can't put anything under 0 under the square root. But what if you could? So that's basically what complex numbers. So you don't solve in the realm of rational numbers, you solve in the realm of complex numbers. Yeah, so you set this equation. Fucking hell. Almost good. Fuck that shit, I'm lighter. Yep, yep, yep. So, first of all, you set the realm. Actually, no. And this means that this symbol just means that basically this domain is the subdomain of this domain. That makes sense. So all of the numbers that are in the rational domain are also in the complex domain, but the complex domain has even something more. And you said basically this. Z is like complex number is A, which is a rational number, plus B, also a rational number, I, where I squared is -1. Can anything squared be equal to -1? That's why it's special. I don't really understand it, to be honest. As I have been saying for a long time, I'm just trying to be like the train monkey. Okay, and learn to solve these problems. I don't really understand why you need this, because you don't even get like good results. But who cares? Whoa. Yeah, so I squared is 1, and this is the complex part. This is the rational part. Wait. Is there anything about complex numbers in my smart book? Not really. Maybe something in like realms and stuff. 19. A little bit guessy. 19. Yeah, we have complex numbers. But other than that, don't think. Yeah, nothing really. So something that holds true for some formulas. Ui equal to what the hell? Okay. So this just tells us that what the fuck? So crazy. So this just what the fuck? This tells us that this number is equal to this number if A is equal to C and B is equal to D. Okay, thank you for that. Okay. So in a roundabout way, it tells us that a number is equal to a number if number is equal to a number. Yes. Not really if, this is like both sides are true, but I was trying to make a joke. Probably it was not fun. Yeah, plus di. Sorry, that's that. Okay. Once again, A plus C plus. So this just means that we can sum them up individually. Okay. A plus I times B plus I equals what? Oh, this is peculiar. AC. Wait, what is C? Oh, well. What? Why did I use B here? What the fuck? Stupid. AC minus BD. This is interesting. What is this formula? Plus AD plus BCI. This will actually probably be useful when multiplying two. The fuck? Why is what the hell? I thought you can just multiply the individual, but I guess I was wrong here. We'll see, we'll see. Okay, okay. We got our first problem, 13.4. And the problem is A is 2 minus 3i. B is minus 2 plus 5i. C is 3 plus 1i. 3 plus I. And they want us to calculate D equals A minus B plus 3C. Okay. Easy enough. So we just do 2 minus 3i minus. You have to treat them like individual numbers. Like this is one number, not two. That's why the multiplication here is you need to have this weird formula. Because, yeah, we'll just get to that. Minus b, that's minus 2 plus 5i plus 3 times 3 plus I. So, when it comes to like summing and subtracting, you can just do the individual guys. So 2 minus minus 2, so that's 4 obviously. Minus 3 minus 5, that's minus 8 I. And then we have to add 3 times 3 plus I, which will yield it's 9 plus 4, which is 13 minus 5i. That's correct. Now, when it comes to, that's correct, but E is equal to, sorry about that, BC. But E is equal to minus 2 plus 5i times 3 plus I. So, actually, I want to try something out. Since we know that I squared is minus 1, let's try to multiply these as if they were individual numbers. Experiment. Sorry about that, I got a notification on my phone. So if we were to multiply that, then it's minus 2 times 3. So that's minus 6 minus 2i plus 15i plus 5i squared. So we are left with minus 6 plus 13i plus 5 times minus 1. Yeah. So we are left with minus 11 plus 13i. However, now we use the formula which I already forgot. A times C minus B we do bing bong, and then you do bing bong, and minus plus. Okay. So you do E is equal to minus 6. Wait, but you still get. Oh, you don't. Okay. Minus 6 plus 5 minus minus 2 plus 15i. Hold on a minute. Almost worked out. So we end up with minus 1. And here we have minus 13i. So as you can see, not the same. Wonder why. Oh no, there's supposed to be a minus there. This is actually supposed to be. Huh. That is peculiar. What? Oh, it's supposed to be plus. I'm dumb. Switched them around. So what is exactly the same? What? So why do I need a fucking formula? What the hell? It's already one correct, one incorrect. Let's mark that down. Bam. 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 Mm-hmm. So yeah, like there's no, the formula is pretty useless for like normal people. So I'm just gonna stick to the fucking multiplication because I don't see the point. No, 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 no. So now we actually want to when it comes to fractions, you have like one imaginary number divided by another imaginary number, which yields which should be like pretty tough, you know, because you have like two numbers that are one number. So what you gonna do? So you use this formula, which probably actually will be useful. So you do z1 over z2 times this z with a dash, which will be explained shortly, times z2. That's equal to z1 times z2 c squared plus d squared. And this z with a dash, there you have. Brother. So let's say you have a z equals a plus by, imaginary number. So just and that's it. Let's do a problem. No, it's off, bro. Okay. We've got 13.7 a 3 minus 2y over 2 plus 3y. So and this is tough, because if it were like normal numbers, you just divide and you are fine. But it's like two numbers that are considered one number. So let's use the formula provided. Also, wait a second. Let's perform another experiment. Come on. Actually, let's not perform. That was stupid. No experiment. So using the formula, we get 3 minus 2i over 2 plus 3i times 2 minus 3i, over 2 plus 3i. Or did that help me? I don't know. Maybe it did. So we get we get 6 minus 2i minus 3i plus 6i squared. That's good. And then we get 4 plus 6i plus 6i plus 9i squared. which yields. This just gets kinda eliminated because it's 6, and then this is 6 times -1, so it's -6. So you end up with -5i over 12i. Wrong format. So we get 4 minus 9, which is -5 plus 12i. What now? This is like the final, like... C squared plus D squared. It's not really what happened, to be honest. What the hell? What the hell? Okay, first of all, what the fuck was I thinking? Okay, so, oh god, man. Am I retarded? I said that, 3... What? Bro, I'm completely fucking retarded. What the f... Okay, so I've got 6 minus what? Minus 9i. Am I retarded? Minus 4i plus 6i paired. Bro, I'm like completely dumb, or what the fuck? And then you get 4 plus 6i plus 6i plus 9i squared. What was I doing? What the fuck? That yields 6 minus 6, and we get minus 13i over what is bullshit. Oh wait, I'm dumb. No, I'm not. What? Fuck, I rewrote the formula incorrectly. Also supposed to be this. But I'm fucking dumb. So there's supposed to be a minus here, which kind of changes the whole thing. So we get 4 plus 6i minus 6i minus 9i. This eliminates itself and we get 13. 13. We get minus I in the end. Yeah. Bro, I'm like super dumb. What the fuck? So many mistakes. So let's try to redeem myself now. Let me play some music. Hmm. Okay. Wait. Oh, fuck it. Enable audio, and I'll just take the strike. So we've got the B 4 plus 5i minus 3 minus 2i. So once again, let's just rewrite it in the format. So we get 4 plus 5i over minus 3 minus 2i times like this, correct. Minus 3 plus 2i over minus 3 plus 2i. So it's the same as multiplying it by 1. That yields 4 minus 3, that's minus 12, minus 15i plus 8i plus 10i squared. My nose is super itchy. And then we get 9 minus 2, sorry, what the fuck? 6i plus 6i minus 4i squared, which yields minus 12. We get minus 22 minus 7i over 9. No, minus, we get plus 13 over 13. Is it? Let's double check, man. 4 times minus 3 is minus 12. 5i minus 3 is minus 15i. 4, that's plus 8i, yeah. Plus 10i squared, yeah. And then this turns into minus I, so we get minus 12 minus 10, that's minus 22. And this, that's 2, and then 5, that's 7, minus 7i. And here it's 9 plus 4, plus 13, yeah. Now, I don't think I can... There like a common... I don't think there is, to be honest. If this was 14 and this was 21, maybe I could craft up something, but I think this is just the result. Yeah. Oh, this is interesting. So say we have a imaginary number here, z a plus b I, then the absolute value of z equal to square root of a squared plus b squared. It's interesting. And the reason for that is draw a line. Say we have the two axes, because that's what imaginary numbers basically are. They are a way to represent single numbers on like a not in a 1D space but in a 2D space kind of. So here we have the x-axis and the y-axis. So this is the imaginary number. This is basically the bi and this is the a, I think, but they don't have it written like that, so I'm not gonna do it. But this is basically the absolute value, which obviously the definition of absolute value is the distance from zero. I have to quickly go ahead and blow my nose. Okay. So this is basically just once again the Pythagorean theorem. It's kind of crazy, bro. It's used in so many places. Oh yeah, and one more thing. This here, the angle. I'm not fucking hell, bro. No. Why is it so crooked, man? Not going to be better. So if you want to express the imaginary number, not by numbers, but by like using an angle value here, you get z equals the absolute value of z times the cosine the angle plus I sine of the angle. Where the cosine is the a coefficient over the absolute value and the sine is the b coefficient over, but I think you have to solve it as a system of equations. That makes sense. Okay, and here we have got ourselves a problem. 1310. Where we have a imaginary number z. 5 times square root of 3. Increase the plus 5i. So, yeah, first let's calculate the absolute value of z, which is square root a, which is 5 squared plus 5 squared. What the fuck, man? If I have two numbers here, do I square them both or just one? I think I square them both, no? I end up with 15 times 3. Hey, let's do a little experiment. Let me pull up a scientific calculator. Let's just say you have 2 times 3. So that's 2 squared times 3 squared is 36. Yeah, so you yes, both. So I end up with the square root of 25 times 3, that's 45. No, that's not at all, that's 75. Plus 25, which yields 10. So the absolute value is 10. And now you know that z is equal to absolute value of z times cosine of the angle plus pi sine of the angle. We do not know these two values. Or do we? I think we do actually. Because we know this. We know what will be here, we know this. Only thing we don't know is this. So I know that 10 Excuse me for a moment, I really need to quickly go to the... Okay. Yeah, which basically means that yeah. So now, do I actually have to solve like a system of equations? So let's divide this by 5. No, let's actually divide it by 10. And divide this also by 10. We get the cosine of the angle is equal to root of 3 over 2. And we have the sine of the angle, which we know is 1/2. I also eliminated the I, because you can just, if you have it on both sides, you can just eliminate it. Now, my favorite time. It's time to rewrite the whole table. Do I need to do it? Fuck it. But I don't think I don't need to do it if I have the tables. Fuck. 0. Pi over 6. Pi over 4. Pi over 3. Pi over 2. Pi 3 pi halves. Then we have 2 pi. We have the sine value. What? 0. 1/2. Root of 2 over 2. Root of 3 over 2. 1, 0, minus 1, 0. Cosine 1, root of 3 over 2. Root of 2 over 2. 1, what the fuck? 1/2, 0, minus 1, 0, 1. Tangent 0. Root of 3 over 3. 1. Root of 3 not defined. 0. Not defined. 0. Not defined. Root of 3. 1. Root of 3 over 3. 0. Not defined. 0. Not defined. Wait, what? Oh, here. 40. Page 40. Root of 2, yeah, blah, blah, blah. It's good. Basically get that 1/2 is here. And that's also here. So we get that equals. And that means that finally we can use this. So we get that z is equal to 10. Let me rewrite this whole times cosine of this plus sine of this, which yields that z equal to 10 times the cosine of pi sixths plus pi sine pi. I have to do the whole. I wonder if I have to do the whole 2k pi here. No. But I got the answer correct, surprisingly. Brother. Okay. Okay, bro. I mean, Euler bullshit here. It's actually surprising to me that they don't have the fucking exponential, like the go to 15. But they don't have the uh they have like calculus here, but they don't have complex numbers. Hmm. Wait, they do 26. Oh, they do indeed. Mm-hmm. Okay, that's good to know, I guess. Anyhow, this is it for complex numbers. But what I'm gonna do is go to the course page and actually solve the complex number problems that are in the mock test. Boo. Because I think there was one problem there. Uh, series. That's equations. Mm-hmm. Okay. We have a problem actually here. Problem from the mock. Come on, bro. It's on the edge of the... Oh, it's not gonna be any better. So, we get z1 is equal to 3 plus 2i. Z2 is equal to 1 minus 2i. And we are supposed to calculate z equals forgot the name of this, but I know what it means. Should be okay, I guess. I don't know why I wrote it so. It is here. Let's rewrite it as z2, so that means 1 plus I plus 3 plus 2i over 1 minus I. So that yields just sum of the things. So that's 4 plus 4i over 1 minus 2i. And now, of course, we have to multiply it by 1 plus I over 1 plus 2i to get rid of the I in the divider. That yields 4 plus 8i plus 4i plus 8i squared over 1 minus 2i is 2i minus 4i squared, which yields this is minus 8, so it'll be minus 4 plus 12i over, this is minus 4, so that's plus 4 over 5. I think that's it. Double check though. Oh, but I already see that I have it correct because so first solution is minus 4 over 5 plus 12i. Let's input it into my good friend and teacher Gemini, just to be like double sure. Yeah, but this is like an easy problem. I hope they don't put something crazy in the exam like the fucking angle bullshit or stuff like that. Yep, that's correct. Correcto mundo. Okay, shut the fuck. Right, 56. 3 goes up to 3. Nice. So, yeah, from what I kinda understand from the mock exam, I hope the mock exam was prepared by the same guy who will prepare the exam. So he's really focused on matrices. Basically like four things are from the matrices. Oh wait, one more thing. What the hell? Fade to black for a moment. Because I want to come back to systems of linear equations. Yep. Because yeah, I want to do there is one linear equation here, one system in the mock test. So I want to solve that. Question 10. From the mock test. And we get 1, 2, 3, 4. 1, 2, let's get 1, 2, 3, 4. Okay, no tricks here. We get minus 1, 5, minus 1, 1, minus 5, 4, minus 2, minus 1, minus 2, plus 10. Oh, minus 2, 2, 4, 1, 1, 2, 9, minus 3, 3, 3. Minus 5, minus 1, 1, minus 5, plus 4, minus 1, minus 2, then minus 2, 2, 4, 1, 1, 2. Okay. Let's get to solving, I guess. Lot of ones here. I wonder what will be the best to use. Let's use this one. x and then use. This one seems kind of cool. Plus 1x. Plus 1x here also. 4. That's 0. 0. Minus 6. 0. 6. 12. Yeah. Yep. Then we get 0. 9. Oh. 9. 0. Minus 9. I am starting to see a pattern here. Then we get 0. Minus 3. 0. 3. We get 6. And then we have the 2. Okay. This is interesting thing here. I'm not sure I like it to be. So it seems to me that minus 3 is going to be 2. Or just going to be 2s. Maybe minus 2 and 2 would make sense. No, minus 1 and 1. Sorry. My bad. How do we solve this though? It doesn't have to be minus 1, it can be like minus 2 plus 2. It can it? Minus 12. No, it can't. Well, let's get to it. I guess. You can remove all of these, but I don't think that will help me to be. Wait, you know what? I have a great idea. I have minus 6x plus 6 over. I've got 9 x2 minus x minus x. And I've got minus 2. Obviously it will be like minus, but I don't want to make a mistake. What if there is something that, some ridiculous solution to this, you know? I'm fucking, you know what? Just fuck it. Just solve it as I know how to solve it, and then I'll interpret the results. So let's do minus 2x here. Let's do plus x, and that yields 1, 2, 3, 4. That means 0, 0, 0. Oh. Yeah. X 0. Get 0, 0. Yep, 0. 0 of 0. Then we get 0 and divide it by 3. 0 minus 1, 0, 1, 2. Yes. And then we get 1 minus 1, 2, 2, 3. It's not ideal, to be honest. We can do plus, sorry, here, which leaves us with, switch them around also, make it a little more readable. 1, 0, 2, 1, 1, and 0 minus 1, 0, 1, 2. Yeah, that's not ideal, to be honest. Not ideal at all. Ay, man. Why does this shit have to be so hard? So we end up with x1 plus 2x plus 1 and minus x plus x a. We are kind of cooked, man. We are kind of cooked here. Why can't it be a nice little aquarium? Maybe I made a mistake somewhere, you know. I probably didn't. 0 minus 6, 0, 6, 12, 0, 9, 0, minus 9, minus 18, 0, minus 3, 0, 3. Yeah, I would think that this just means that this is like minus 1 and this is 1. But then I edit it more and now it can mean like fucking minus 52 and 55, you know. I'm confused. And all I did was fucking reroll. I'm struggling a bit to understand. So let's say that x2 minus 1 and x4 is... Does not help me at all. By the way, I have this wrong. x4. I'm still missing x3. And x1. Am I regarded or what? Is this even true? Wait, fuck this. So let's just say I take these two equations. And let's say I name them x and y because put them in a system. Divide by 6, divide by 9. End up with minus x plus y equals 2. And x minus y equals minus 2. So let's say that y x plus 2. So we get x minus x plus 2 equals minus 2. We get x minus 2 equals minus 2. We get 0 equals 0. So the problem means that x2, x4 can be anything. x1, I don't know. So let's say that they have infinite solutions because this can be anything, but two variables can be anything. But I don't know how to fucking... How do I know this? I'm left with this shit. But if this can be anything, like how does this then make sense? You know? Ay, ay, ay. Bro, I don't know, man. I don't know, I'm confused. Ask. Fucking hell. Freak. That's my only friend, Google Gemini. There was a way. There was a way. Maybe it will be written here. I remember there was a way to... Gonna solve these. 29 maybe. 29. Yeah, so you end up with basically what I have. Cool. Yeah, so this is how, yeah. Maybe I made a mistake by doing this. We get 0, 0, 0, 0, 0, 0, 0, 0, 0. And this just means because the rank of the matrix, let's say A, is 2, because it has 2, and there are 4 unknowns. Unlimited solutions and 2. Okay. I have to remember this. The Frobenius law. There's nothing here on it. There's calculus, arithmetics, algebraic functions. Yeah, but nothing else. Okay, but that's at least I learned something. So I guess this will be for my morning session. I'll be back soon probably, because I am kinda hyped to get the last thing, which is series and series and that's it. But yeah, this is it for me, guys. I'll see you later soon. I'll probably do my session like early, and then in the evening I have to finish another project for school. So yeah,